Hello, today we shall discuss about the various phases of a compiler. Let us begin with the introduction. What is a compiler and what do a compiler do? Compiler is a program that converts a program which is written in the high-level language into a program which is in the machine language. That is, it translates the source code into a target code. If the source program has any errors, either syntax or semantic errors, the compiler is going to declare error messages. If you see the structure of a program, there are two parts in it, the analysis part and the synthesis part. The analysis part breaks the source program into manageable pieces and imposes grammatical structure on it. If the analysis part detects that the source program is syntactically or semantically incorrect, it reports error messages. Also, the analysis part collects some information about the source program and stores it in a data structure called as single table. The output of the analysis is an intermediate representation of the source code. The synthesis part constructs the desired target code from the intermediate representation of the source code and also the information stored in the single table. The analysis part is called as the front end of the compiler, and synthesis part is called as the back end of the compiler. If we examine the compilation process, we see that it operates as a sequence of phases. The first three phases are part of the analysis part, and the last two phases are in the synthesis part of the compiler. These phases are going to use a data structure called as a single table. It stores the information about the identifier used in the program, such as name of variable, constant, function name, etc. The first phase of the lexical compiler, that is a lexical analyzer or the scanner, or also called as tokenizer, which is going to read the source program character by character and groups them into a meaningful sequence called as lexi. The lexical analyzer generates token corresponding to the lexi, that is scan, as defined in the language. The stream of token that is generated by the lexical analyzer is given as input to the second phase of the compiler, that is syntax analyzer, which is going to check the syntax of the program. A syntax analyzer is also called as parser. If there are any syntax error in the program, the syntax analyzer is going to report error messages. For the token stream generated by the lexical analyzer, the syntax analyzer is going to construct a tree-like representation called the syntax tree, which depicts the grammatical structure of the program. The output of the syntax analyzer, that the syntax tree, is given as input to the next phase of the compiler, which is called a semantic analyzer, which takes the information that is stored in the single table also to check the source program for semantic consistency with the language definition. It also gathers the information, also saves it in the syntax tree or single table. The output of the semantic analyzer is the intermediate representation. Few examples for the semantic chess are success. Suppose if there is an operation in the source code, the semantic analyzer will see to it that all the operands of the operations are matching type, that is type checking. Also, if required, it does the implicit type conversion also. The output of the semantic analyzer is the intermediate representation that is input to the optimizer. There are various kinds of intermediate representations are available, such as three-address code, triple, and quadruple. Two techniques of intermediate representation are that it should be easy to produce intermediate code, as well as it should be easy to translate the intermediate representation into the target code. The next phase of the compiler is the optimization phase, wherein the optimizer is going to identify the redundant code or the code which has the same number of operations repeated. The objective of the optimization is to reduce the size of the code as well as to generate a code which takes less power. So the code optimizer is going to replace inefficient sequence of instruction with better sequence of instruction so that better target code will result. The output of the target code optimizer is given as input to the code generator, which is going to generate the target code corresponding to the machine. But the target code can be assembly language code or combination language code. If the target code is an assembly language code, the code generator is going to identify the register to be used or mnemonics to be used in the instruction. So this is about different cases of the compiler. Let us take an example. In the example, a position is equal to initial plus rate star 60 is an instruction in the high-level language code. This instruction is fed as input to the lexical analyzer, which duly tokenize this instruction. It generates tokens as identifier followed by a token equal to assignment token, identifier token, second identifier as well as the operation plus, and the third identifier token and the multiplication operation as a token, and the last token as consequence. So it's going to generate a stream of tokens which is given as an input to the syntax analyzer, which is going to construct the syntax state for the class tree corresponding to the stream of tokens. The next step of the compiler is the semantic analyzer, which inserts the type information in the syntax tree and modifies the syntax tree appropriately. Assuming that all the operands are of real type, the 60 is integer type, it has to be converted to real type before the operation multiplication is applied. So the semantic analyzer inserts an additional operation into float real conversion to convert the value 60 to real value. So modified syntax tree is given as input to the intermediate code generation, which is going to generate the intermediate representation of the source code. In this example, we have used the pre-address code intermediate representation, wherein every instruction can have maximum 3 addresses in the neighbor. Also, on the right hand side of the assignment operation, we can have at most one operation in it. So in order to get this type of instruction, the intermediate code generator is going to use many temporary variables. The next step of the compiler is the optimization phase, which is going to reduce the size of the code by identifying the redundant code or common subexpression in the code. In this example, we see that instead of applying a new operation, separate operation into real conversion, if we replace the operation as a constant 60 in the multiplication operation, the size of the code can be reduced. Such type of modification or optimization is done by the code optimizer. Also, there is a redundant assignment operation which is removed by the code optimizer. Output of the code optimizer given as input to the code generator, which is going to generate the target code corresponding to the machine. In this example, we have the assembly language code as the target code. So this is about the various stages of the compiler. So in all these cases are either using the information in the symbol table or to store the information in the symbol table. Thank you.